This one is from your homework, but it will also help you with a learning catalytics module, 82.2.3, energy transfers right here. Okay, so we have 3 liquids at different temperatures, and then you have different mixtures. So it says that you mix the first 2, and then you mix the second and third. And what we need to know is, what is the temperature when you mix equal masses of the first and third? Okay, all right. So let's do this. Let's write down what we know. All right, so I label the mixture of the first 2 liquids with T12, with the temperature, and then second and third, T23. So we need to find T13, first and third. Because all the masses are the same, I'm just going to call it M. So the first thing we have to do, and this is the way in which you should answer your learning catalytics question, the first thing we have to do is express C2 in terms of C1. So we're having an exchange of energy. So we know that Q1 is equal to Q2. Heat transfer 1 equals heat transfer 2. And we know this because there'll be an energy exchange between the second and third liquid going like this, right? Because this is hotter. So because the masses are the same, we can just ignore them. Now what we need to do is just set up our delta T in such a way that we have a positive number. So we just have to be looking at T1, T2, and T12. So for our left side, it's going to be T12 minus T1, and then for the right side, it's going to be T2 minus T1. Now let's solve for C2. So all we got to do is divide by my expression inside the parentheses. And there you have it. This is what you would write as your answer for the first question on learning catalytics. To make this problem easier, I am going to plug in my numbers, otherwise my final expression, or my final equation would be very, very messy. I'm also going to move my C1, because I don't know that one, to the side. All right, the reason why I don't have units is I'm going to divide degrees Celsius over degrees Celsius so they cancel out. Okay. And then our next step is going to be write C3 in terms of C2. Same thing as we did before. Because the third liquid has the higher temperature, we know that there'll be a temperature exchange flowing from the third liquid to the second liquid. We cancel the masses, and we solve for C3. So this should be the answer for the second learning catalytics question. Now, let me plug in my numbers. Again, I'm going to move C2 to the side. What I'm going to do now is, because I know what C2 is in terms of C1, well, I'm going to substitute this expression here. All right, there you have it. Now we can see what's going to happen with liquids 1 and 3. So again, liquid 3 is the one with the higher temperature. So then I know there'll be a heat exchange between, well, energy transfer via heat from liquid 3 to liquid 1. So now what we need to do is we need to write T3 in terms of other variables. So let's cancel the mass. All right. Don't forget that we already have an expression for our heat capacity. Before we do that though, let's distribute. All right. We're looking for T13, so I'm going to move this to this side and then this one to that side. My goal here is to have all my unknowns, which is T13 on one side and everything else on the other side. Now let's factor out that T13 and let's divide by those heat capacities. Okay, so what do we do with that? Don't forget what we derived on the first two steps. Now we can use it because we know what C3 is in terms of C1. Right here. We know this. So let's use it to our advantage. Let me bring it over here so I don't forget what it is, because I will. So I decided to get rid of the parentheses so it is a bit more clear what I'm going to do. So notice how everything has C1, meaning that I'm going to factor it out. And there we have it. So now, oh, I missed a T3 over here. Hopefully you saw my mistake. Now we can plug our numbers in because C1 will be canceled. After I plugged in my numbers, you can see it is 24.943. Yeah, 943 is fine. And that's degrees Celsius because of the units. And that's it.